Hi everyone, and welcome to the video on prime factorization. What prime factorization is almost exactly what it sounds like. It's breaking a number into its factors, a string of factors that are only prime numbers. A prime number is a number whose factors are only one in itself. So in prime factorization, we take numbers that are composite, aka not prime, have more than two factors, and break them down into their longest factor string of only prime numbers. So in this video, I'm going to show you an example and then give you a couple of prime factorization problems to practice. So let's get started. Let's start with the number 60. So we start by writing out the number 60. Then the first thing we have to think about is, what are two factors of 60? I don't have to know all the factors of 60, I just have to start with two. So with 60, I think I could start out with 6 and 10, I could start out with 5 and 12, I could start out with 2 and 30. I could really start out with any two factors. I think I'm going to start out with 6 and 10. Then I know 6 times 10 equals 60, so that's how I got those. And then I have to ask myself, are either of these prime? Well, 6 isn't prime and 10 isn't prime, so I have to keep going. So I'm going to find factors of both 6 and 10. So let's see here. Factors of 6 are 2 and 3. All right, well, 2 is prime and 3 is prime, so I know I'm finished with this side, so I'm going to circle these numbers to signal to myself that I've found some primes. And then I know I have to find factors of 10. Well, I know that 2 times 5 is 10. Hey, look at that. Both 2 and 5 are prime, so I'm going to circle those. And now all of the numbers that I found are prime, so I don't have any more numbers to factor. And my last step is to take all of these and write them into a multiplication string. So normally I write them in order from least to greatest. So I'm going to say 2 times this other 2 times this 3 times this 5. All right, and we can check that out, make sure it really does equal 60. 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. Awesome. We are correct. And if we want to go one step further, we can write this in exponential form. If we have any bases like this that are repeated, we can write that in exponential form. So I see 2 times 2, which I can write as 2 squared, or 2 to the power of 2, times 3 times 5. And those all equal 60. Now, back at the beginning, I had mentioned, well, we could choose any two factors to start with, and I want to show you that we could have chosen something other than 6 and 10 and still get the same prime factorization. So let's try this again, but instead of starting with 6 and 10, let's say we had started with 2 and 30. 2 times 30 does equal 60. Well, here, oh, well, one of these factors is already prime. That's great. So I start by circling that because it's prime. Now I'll find two factors of 30. I could do 3 and 10. Let's do 2 and 15. Great, I'm going to circle this 2. That's prime. And 15 is not prime, so I have to keep going. Let's think 3 times 5 is 15. 3's prime, circle it. 5's prime, circle that. And again, looks like all of the numbers now are prime. So I will write this out in a long factor string. 2 times 2 times 3 times 5, also known as 2 squared times 3 times 5. And if you look, we have the same prime factorization here as we did when we started with two different factors. That should be the case because each number has its own unique prime factorization. There's no other number, if we multiply 2 times 2 times 3 times 5, we'll only get 60 every single time. That's what's so cool about prime factorization. So now let me give you some problems to practice. So go ahead and let's practice with the number 112. So if you want to practice this on your own, go ahead and stop the video and then pick it up to check your work. So if you're checking your work on 112, if you prime factorize that, you may have started with something different than I did, but check to make sure you got the same prime factorization at the end. So I started with 2 times 56. I know 2 times 56 equals 112. 2 is prime, so I'm going to circle that. 56 is not prime, so I'll keep going. I know 7 times 8 is 56. 7's prime, so I'll circle it. 8 is not prime, so I'll keep going. 2 times 4 is 8. 2's prime, I'll circle it. 4 is not prime, I'll keep going. So 2 times 2 equals 4. Circle 2, it's prime. Circle 2, it's prime. And it looks like I've got 1, 2, 3, 4 2's. So I'll write this out as 2 times 2 times 2 times 2. And that 7 times 7. That is also equal to 2 to the 4th power times 7. And both of these equal 112. Pretty cool, right? All right, let's try one more practice problem. If you're playing along at home, you can stop the video to try to solve this on your own and then check it. So go ahead and pause it now. And if you're checking your work for 100, again, you might have started with some different factors than I did. When I was prime factorizing 100, I started with 2 and 50. But remember, you could have started with 10 and 10. You could have started with 4 and 25. You should get the same thing. 2 is prime, so I'll circle it. 50, let's think of two factors. I'm going to do 5 times 10. 5 is prime, circle it. 10 is not prime, it's composite. Let's keep going. Two factors of 10 are 2 and 5. They're both prime, excellent. All my factors are prime. So I'm going to write this out in the prime factorization of 100 as 2 times 2 times 5 times 5. I can also write this as 2 squared, or 2 to the power of 2, times 5 squared, 5 to the power of 2. And I know both of these are equal to 100. I could also check. 2 times 2 is 4. 4 times 5 is 20. 20 times 5 is 100. Down here, 2 squared is 4. And 5 squared is 25. 4 times 25 is 100. We are correct. And thanks for watching the video on prime factorization.